Why, hello. I hope you can hear this okay. I haven't done one of these in a while. Sorry. But by request, some students had asked if I could do this particular assignment because it's a toughie, I'm not going to lie. So, here's what we're going to do. We're going to go through all the problems on here. Uh, these are going to be problem types you'll see on a future assessment. So, maybe the ones I do now will help you in the future, or help you get your homework done at the very least, you know what I mean? So here we go. We're going to do systems of equations, the word problems. All right, word problems, word problems, word problems. Here we go. Laura will rent a car for the weekend. She can choose one of two plans. The first plan has an initial fee of $44 and costs 10 cents per mile driven. The second plan has an initial fee of $49 and it has 8 cents per mile driven. So I'm going to have to show you how to do the work because as I've been reiterating all week and all chapter long, at least up until this point, I do not want you to solve using anything besides your own work shown on paper, etc., etc. So here, let me open up some paint here. Get this all nice for us. Boop. Okay. Let's half and half it, Okay, so make sure this guy still works. I'm going to use this in a minute. Okay, here we go. So there's two plans. So when I'm talking about the cost of a plan, I'm talking about, we're going to use variables. I'm going to use y. Y is the cost of a plan. We don't know what the cost of the plan is, but we know that the first plan it costs $44 for sure, plus they charge you 10 cents per mile driven. That's it. That's an equation. The second plan, which is also arguably equal to y, because that's the cost of a plan, is $49 plus 8 cents per mile. Now, I think I see people writing this okay, but they're getting some kind of disconnect between what to do. So here's the deal. This stuff that's equal to y on the right, and this other numerical and x stuff that's on the right here, these are equal to each other. Why are they equal to each other? Because the red stuff is equal to y, the blue stuff is equal to y, so wouldn't it make sense that the red stuff is equal to the blue stuff? Right, because if they're both equal to y, they're equal to each other. So I guess you don't have to write, if you were showing your work on a test or something, I would be okay if you started by writing what I'm writing right now. The setup of comparing these equal to each other. It kind of helps to write the stuff up above. You'll see at the end here. All right, now what you do is you solve this. So we've seen these equations before. We've got some decimals, whatever. We have x on both sides of the equation. That's the first thing we got to move. I see a lot of people not getting rid of this stuff first. I mean, I'm not saying it's wrong. I just feel like you're more likely to make a mistake if you don't do it first. So I minus 0.8x on both sides. I'm choosing that because that's the lesser of the two numbers. And my results is 44 plus 0.02x equals 49. Okay. Actually, you know what? I think I'm going to set my writing thing down. We'll see if that helps. Oh, maybe it does. I'm always wondering what I can do to make the writing work a little bit better. All right. Then I'm going to minus 44 on both sides. Get 0.02x equals 5. I divide by 0.02. And 0.02 goes into 5. I mean, that's probably a job for a calculator, but I get 250 times. So the first answer here is, for what amount of driving do the plans cost the same? Well, that's the whole point of us setting them equal to each other. We wanted to know when they cost the same. What do you plug in to make them the same? 250. Then what will be the cost when they're the same? Now, the stuff I wrote down here won't help you answer that. Sort of. You have to plug it into one of those original ones, basically. Hold on. Thought I was going to sneeze. No? No sneeze? I'm talking about it, so now I won't. Of course. Okay, so what I'm saying is, to get the second one, what would the cost be when they're the same? Is you take your answer of 250 and you plug it back into either one of these equations. I'm kind of running out of room, but I will attempt to do it on the top here. So we have, I'm going to use the red equation, okay? As usual, the pin's being janky. All right, so I'm going to write y equals 44 plus 0.10 times 250, taking the x out, writing 250, and I get y equals 44 plus, and 10 cents times 250 is 25, and y equals, these add up to make 6.9. No, no, there we go. Now, I'm going to show you this, okay? I'm not saying this is illegal to do, okay? I'm saying this is not the way you are supposed to answer the question only. When I give you guys an assessment, I'm looking for all this. I know this is a lot. Word problems are a lot. Systems of equations are a lot. But I do recommend this. If you go to desmos.com and you type in the equations you made, y equals 49 plus 008 x. All right, the lines are graphed, but you can't see them. They're very zoomed out. And they meet at 250, 69, which means the x value, the thing you plug in, which is how many miles, and 69, the cost at the point in time where they cost the same. Now, that's just to confirm your answer is right. Please do not use this as a way to answer the problem. I will not accept that. I want work. Most of your test points are going to come from work. I'm just telling you this in case you want to make sure you're right. Because being right also will give you some points. Don't get me wrong. So make sure you try it if you want to, okay? All right, let's continue. All right, another one. A phone company charges a monthly fee plus some extra money per minute of calls. So we got plan A and we got plan B. So this is just like the last problem, just different kind of context, I guess. Here we go. So y equals $11 plus 0.13x. Y equals 15 plus 0.09x. Those from plan A, $11 plus the 13 cents per minute and $15.09 per minute. Same deal as last time. Set them equal to each other. I feel like I really shouldn't do two of these. I mean, I should give you two of these to practice, but hopefully the first one was explaining enough because I'm not going to try as hard to explain this one. So same thing, x on both sides, subtract. So I get 11 plus 0.04x equals 15. I minus 11 on both sides. These cancel out. I get 0.04x equals 4. I divide by 0.04, get a calculator out or whatever, and divide that. This should be 100. So after 100 minutes of call times, the cost would be the same for both phone plans. And what would that cost be? You go back and plug it in. Doesn't take a lot of space. I'll just do it in the top here. I'll use the top equation. So y equals 11 plus 0.13 times 100. Y equals 11 plus 13. That's what 13.13 times 100 is. So 11 plus 13 equals 24. Wish I was only paying $24 for a phone plan. Then again, that's only 100 minutes of talk. I'd probably do more than that. I don't know. Sorry, my face is covering up the 100 in the bottom there. So let me explain those first two problems. There's almost a guarantee, I think, of one of those problems being on the test. So I'm to break down the problem to its like basic setup. They're giving you information that you would want to set up in slope-intercept form, like we did on this. So some starting amount plus some amount per minute or per mile or per this or per that. So you're getting y equals this and y equals this. And in those situations where you have y on one side, you're going to set the x stuff equal to each other because one thing equals y, the other thing. What you're technically doing is substitution. What you're technically doing is, let me write this in a color here. You're technically taking this stuff right here and you're replacing the y on the left side with it. See, notice down below, I took the y out and I wrote the green stuff equals the right side. That's all you're doing. So that you're going to get one like that where you have two slope-intercept form style equations you're going to make, set them equal to each other, and then use that information to help you solve the problem, okay? All right, next up, we got some problems with a description about some numbers. So the sum of two numbers is 36. X plus y equals 36. See, you don't know what either of the numbers are. So x is one of the numbers you don't know. Y is the other number you don't know. They said the sum, which means I add, and it's 36. Okay? It's not always, I don't think they're always going to give you the sum, but I got to admit, I've seen a lot of problems that said the sum. So maybe you will get the sum as the first sentence. The second sentence has varied. One number is 3 times as large as the other. So that would be y equals 3x. You could write x equals 3y, y equals 3x. It really doesn't matter. All you're saying here is that some number, you don't know, y, is 3 times as much as the other number, right? Okay, now what do you do here? Well, just like I was describing on that last problem, you're going to substitute. You're going to take this stuff that y equals the 3x, and you're going to put it in place of the y. So I'm going to rewrite the top row. X plus y equals 36, but I'm going to write x plus 3x equals 36. The y is gone. It has now become 3x. Now these are like terms. 4x, because technically this is 1. Divide by 4. You get x equals 9. Now you can't answer that yet. We don't know if that's the larger or smaller. Well, so sorry. I know it's the smaller, but maybe you shouldn't push anything till you found the other number and be sure. So you take the 9 and you plug it in. You can plug it into the first equation, basically subtract 9 from 36 to find the other number, or you can plug it into the second equation. That's what I'm going to do, because it would just be 3 times as much as 9, which is 27. So then you just take a look at them and fill accordingly. The larger number is 27. The smaller number is 9. I'll say it now. I think there's going to be more of these. Good. There's definitely going to be one of these on the test too. So some kind of setup of a first equation based on what they say, and some kind of setup of the second equation, and you do what you got to do. On this problem, I substituted because it made sense to take y out and turn it into 3x. On this next problem, however, I'm not going to use substitution, and I'll show you why. The sum of two numbers is 49. Oops. You know what? I'm going to write x first. I just like writing x first. It's not like it would be wrong. X plus y equals 49, so similar to the last one. Then it says, and the difference is 13. So on that, when it says the difference is 13, instead of x plus y is 49, x minus y is 13. Now on the last one I substituted. That was because I had y by itself and y equaled 3x, so it was okay to put 3x. In this case, x and y are not by themselves. However, they are in a very nice aligned position to add these equations together, because if I did, x plus x would make 2x, y plus negative y cancels out, essentially makes 0, and 49 plus 13 makes 62. So I'm using elimination here, another one of the methods we learned. Dividing by 2 gives me x equals 31, so I found one of the numbers. I'm going to guess 31 is the larger number, but let's not make assumptions, let's just plug it in. I'm going to rewrite the first equation, x plus y equals 49. 31 plus y equals 49. So see what I've done is I've taken x out and turned it into the number. I then subtract 31. If this feels like mental math to you, I would have the very least like you to show me that you're writing 49 minus 31 to show how you're getting the other answer. 31. Sorry, I had to think about what the numbers were. I looked at so many numbers on the screen just a second. Okay, just going back to this again. Desmos still works, okay? I'm just saying, don't do this to answer the question. I just want to show you again how it can be used. The problem is on these ones, you have to make sure you're making the right equation. You don't make the right equation, it's going to be wrong either way, whether you use a graphing calculator or not. So if I zoom it in, I get 31, 18. And that tells you x is 31, y is 18. But it doesn't really matter. I guess if the answer wants you to put larger number and smaller number. But again, that is to check. All I care is that I see this work over here on my right side of my screen. I don't really care about the answer being right or wrong. I mean, I care. I want to make sure you know how to do it. So be careful, okay? All right, there's definitely, I'm positive there's going to be one of those on the test. Sorry. There's three kinds of problems on the test, and we've seen two of the kinds you're going to see so far, okay? Oh, I forgot to say this though. Hold on. Let me go back to number 4. Okay, hold on. I want to hit try another until I get what I want. Okay, this is what I want. Oh, this is perfect. This is exactly what I want. I'm showing you one more of these. I know I just did this one, but I want to show you one more, okay? So, this one says the sum of two numbers is 47. And it says the smaller number is 7 less than the larger. I didn't get a description like that earlier. I got a 3 times as large, and I got the difference. You may also be given something this much bigger or smaller. So in this case, when it says a number is 7 less than the other, y equals x minus 7. The one number, y, is equal to the other number, 7, if it was 7 less. That's how you have to set. You may not. I'm gonna write this. You may not write 7 less than another number like that. That is wrong. That doesn't work. Scribble it out. No good. Don't even think about it. We don't do that. Only x minus 7, not 7 minus x. Otherwise, you're doing it wrong. Okay? All right, I'm just going to go ahead and enter the answer on account that I don't want to do the whole problem out, but I'm just showing you how to set it up, okay? In this situation, it would be prudent to substitute in for y. And go from there. All right, another kind of problem. A fruit company delivers fruits in 2 types of boxes, large and small. Delivery of 6 large boxes, so I'm going to say 6x, and 5 small boxes, so plus 5y, has a total weight of 127 kilograms. A delivery of 2 large boxes, 2x, and 3 small boxes is a weight of 51 kilograms. So that's how you want to set this up. This is giving you information in a way where you're not writing it in slope-intercept form like our first problems. You're writing it in point-slope form. So on point-slope form, x and y are going to be on the same side because you have this kind of box plus that kind of box equals this total. This kind of many of this box and that many of that box makes this kind of total, you know? Now here's the deal. You are supposed to use elimination, but you can't just eliminate by default because there's crud in the way. I have to select here. Hold on a minute. I'm going to scoot this over. Okay. Why am I going to scoot this over? Because with elimination, you want to line the numbers up so that they cancel. 6 does not cancel with 2. 5 doesn't cancel with 3. We had a problem earlier where y canceled with negative y on those number relationship problems. In this case, what I would do is this. I mean, it's up to you, but this seems the easiest to me. Bottom row times negative 3. Why am I doing that? You have to think ahead. Negative 3 times 2 will make negative 6. And when I add the equations together, a negative 6x will cancel with a regular 6x. So here's what's going to happen. Here's the first equation again. Here's the second equation after I multiply. So negative 6x. Then I'm going to do one of these. Negative 9y. Then don't forget the number. I've seen people do that sometimes, so please don't. Be careful. Negative 153. And then you can add this stuff together. So x's cancel out. This makes negative 4y. 127 and negative 153 make negative... What does it make? Negative 20... Wait a second. I'm second guessing myself. Now here's a very good reason to use Desmos. I'm not saying don't use Desmos on your test. Obviously use it for calculation. Okay, that's what I thought it was. That seemed weird to me. I'll tell you why it seemed weird to me. Because 4 does not go into 26. But then again, I guess a box could weigh some fractional pound. So negative 26 divided by 4 will be 6.5. Well, negative 26 and negative 4, yeah. 6.5. Weird. Now, you have to make sure you put these in the right box. It would be a shame for you to miss it because you put it the wrong way. It says the weight of each large box, the weight of each small box. Well, what did I just find? Well, keep in mind, I found y, and y was related to 5 and 3, which were the small boxes up in the earlier words of the problem. So I have just found the weight of a small box. Okay, now how do you find the weight of a large box? Well, you got to go back and plug 6.5 back into the equation. I'm sorry. Not really sorry. Let me get my mouse here. Hold up. I need some space. This is convenient. Scroll down a little bit. All right, here we go. So I'm going to plug this into the formula. So I'm going to use the first equation, 6x plus 5 times 6.5. I'm replacing the y with the number that y equaled. You could use the first equation, the second equation, which arguably could have been better here, whatever, or you could use the second equation after you multiplied. I'd probably just use one of the originals to be safe. Anyway, so you get 6x plus 5 times 6.5 is 32.5. 27. Okay, we got some steps here. We're going to minus 32.5. So you get 6x equals, calculator time, 94.5. Oops. And then we divide by 6. I'm sorry, it's so... Oh. I'm trying to write it in the bottom right of the screen. You can't see that part of the screen, Dedoy. You also couldn't see me write minus 32.5 under here. So sorry. Whatever, I'll just write the final answer up here. I know that's a little weird, but I have to apologize. I'm doing 94.5 divided by 6, which will be 15.75, I think. But you know what? I'm just going to check. I'm going to check by doing 15.75 indeed. And if you waited till the end of the problem and you weren't sure which size of box was which, apparently this one is this one. I'm concerned about these answers. They seem really weird that they're decimals like this, but whatever. Okay, that's good, I guess. Again, I guess I could have checked on Desmos before I hit enter, just so I could know I'm right or not. That was a doozy of a problem. Let's do another one. How many of these did I do? Good grief. Maybe I'll do 2 like the rest. All right, a chair company or a party company has chairs and tables for rent. 8 chairs, 4 tables is $37 of cost. 3 chairs and 2 tables is $17 of cost. What is the cost of rent each? Sad, I forgot to leave some space. Let me leave some space. I'm leaving some space because I'm going to need to multiply here. I want to multiply the I'm going to multiply the bottom row by -2. If you're wondering why I'm doing -2, it's not to cancel 8 with 3. Some people like to cancel x every time. I guess that's okay. It might be more work if you do it that way. I'm thinking about y. Look at 4y, and 2 times -2 will make -4. So that'll cancel out real nice. So 8x and 4y equals 37. -6x minus 4y equals -34. Okay, combine these together. Change my color back to black here. 8 minus 6 is 2. The y's cancel out. 37 minus 34 is 3. I divide by 2. Looks like I'm going to get decimals again, 1.5. I found the value of x. X was the chairs. Notice up on top I did 8x and 3x. That represents the chairs. So the cost of renting chairs is 1.50. If you want to use money, it would be appropriate to add an extra 0 at the end. Okay, now we go back and we find y. I'm going to use the second equation. 3x, I'm going to put 150 in for x. 2y equals 17. 450 plus 2y equals 17. And I minus 450. And then 2y equals 13. No, 12.5? Yes, 17 minus 4 is 13 minus 0.5. Yeah, okay. Math. Then I divided by this. And I got space this time, I guess. Y equals 6.25. So the cost to rent a table is a bit more than a chair, which seems to make sense. I would agree that's probably the case, right? Hold on, I'm going to take a quick drink here. You didn't hear a thing I just said because I had the mic on mute. Butterfly Wonderland cup. I'm a genius. Oh my goodness. This is another one. I'm really disinterested in solving it, I think. So here's what I'm going to do for you. I'm going to set it up at least. If you can set it up, I think you can solve it. The first mechanic worked 5 hours. And we don't know how much he gets paid per hour. That's really what the problem says. It might be good to go to the end of the problem. What is the charge rate per hour by each mechanic? Well, one guy works 5 hours and charges this much. We don't know. The other guy worked 15 hours and charges this much. We don't know that either. But what I do know is that after they charged, they got $1,850. And then it says, now this is tricky because they don't really give you a second equation. But it does say this: if the sum of the two rates is 200 per hour. So this is where a tricky answer is involved, or a tricky setup is involved. X plus Y equals 200. The amount one guy charges per hour plus the amount the other guy charges per hour equals $200 that needs to be charged. Good deal? All right, do I want to solve this? I really don't want to solve this. Hold on. Let me at least get the answer in my head if I can. -5, 850, divided by 10, 85. Okay, so this guy charges 85 and this guy charges 115. Mental math, I hope. Okay, yeah, I have to apologize. I didn't answer the question, but I really want to save time. I'm going on for 26 minutes. Who is still watching this, honestly? All right, next question. Similar, probably going to skip it, but let me show you the setup. One car gets 25 miles per gallon times some amount of gallons it used. A second car gets 40 miles per gallon times some amount of gallons it used. And together, they caused 1,175 miles to be driven. Okay, then like the last one, a tricky setup again. The total gas consumption is 35 gallons. The amount one car used plus the amount the other car used is 35. Oh my gosh, I keep deleting it because I keep clicking the pen delete backup button. Oh, what am I going to do here for this one? 25. Let's see, 15. Oh, I don't want to use decimals to answer the question, but I do need to do a calculation on it. 300 divided by 15 is 20. Okay. I was just answering the question. Sorry. This solves like anything else. Like honestly, what I did just now, I mean I didn't write it down, but what I did was I multiplied by -25 so that the x's would cancel out. Then I worked out some stuff. Sorry I went fast, but you've already seen like a lot of these. Who is still watching the video? All right, now I'm going to do this one fully because this one is not like the other problems we had. And I didn't put it on the test, but it's a very likely problem you could see in the future. And it does one thing that's a little tricky. But otherwise, well, it does two things that are tricky. So the first thing is it talks about these percentages. Mixing 30% this and 55% that, and you're trying to get a 40% solution. How do you mix 30% stuff with 55% stuff to get a 40% stuff? Well, you have to make 180 pints, too. So here's the deal. You write 0.30x plus 0.55y equals 0.4. So here it is. You get mixing 30% solution of this with this much, 55% solution that much, and you want 4% solution, 40% solution. The problem is you don't want to just put 0.40 over here. You actually, this is tricky part. This is one of the tricky parts. You have to put the percent you want times how much you want. So two tricky things going on. We got decimals. That's always a bother, and we've got the setup here where they never gave us a number that actually goes on the right side. You have to find it by doing the percentage of juice you want times however much juice you want. Ooh, crunch on my neck feels good, man. Okay, so anyways, here's what we do. We'll make another equation. X plus y equals 180. Where am I getting that from? Well, they want to make 180 pints of mixture, right? So the amount of this kind of mixture plus the amount of that kind of mixture should equal 180 pints of mixture. Now, I got good news for you. If you hate decimals, you can fix that right now. You're technically multiplying by 100. And when you multiply by 100, it moves the decimal over twice. So this 0.30 just became 30. But you can't just do that. You have to do it to everything. So this moves over twice. And I haven't multiplied 0.40 times 180 yet, but let's just turn this 0.40 into 40. You do not need to move the decimal in 180. This 40 times 180 is all, I don't know, one big piece. So you can move the decimal on the 40 and it's covered. You don't need to do the 180. Okay? Now, that being said, I got to think about what I want to multiply to make the bottom cancel out. So I'm going to multiply it by negative 30. So let me write my two new equations. I get 30x, 55y, and then 40 times 180 is 7200. That's a big one. Then on the bottom row, we got negative 30x, negative 30y, and then 180 times 30, which is negative 5400. So I fixed the first one up so it's no decimals. I fixed the second one up so that it would cancel with the first one. At least the x's will cancel out. I get 25y equals, this adds up to 1800. Does that add up to 1800? That adds up to 1800. Then I divide by 25. I get 4 times 18, whatever that is, 72. So the second fruit drink is 72. Why do I know it's the second? Because, well, I made y the second fruit drink, the kind that was the 55% kind. Now I got to go back and plug it in. Here's what I'm going to plug it into. I'm going to plug it into this x plus y equals 180. That's easy to plug it into. So I'm going to write x plus 72 equals 180. And minus 72. I get x equals 108. This is the level of work I'd expect on a problem like this. But again, you're going to do problems where you have to solve the system of equations, but you won't have to set up one with the percentages on it. I apologize. It's a good idea. You should really see it. But I'm not going to force you to remember all that on the test. That's just an extra thing to know, you know. If you remember it later on a AZ merit or something, good for you. I hope you do. All right, a motorboat travels this many hours, this many kilometers and this many hours going upstream and 378 kilometers going downstream in the same amount of time. So here's how you set this up. Now, to do one of these, you'd have to know that the distance equals the rate times the time, like that physics formula. So in this case, I'm filling it in. The distance, 210, that's what they told me over here, equals the rate. Now, this is where stuff is tricky. The rate isn't just your speed. We don't know your speed. But it's not just your speed. You're going upstream, which means it's the boat speed. I'm going to put B minus C. Because they want to know about the current. Like the current, when you go upstream, is pushing against your boat. Like it's holding you back. So you're going this fast, but you're losing some speed because the current's fighting you. But it takes 6 hours. Similarly, you can go 378 kilometers going downstream. When you go downstream, the current is helping you along, not hurting you or whatever. And it says it does that in the same amount of time. Now here's what I'm going to do. I'm going to advise you when you solve these. These sixes should be distributed. But instead of distributing them, how about we divide first? The cost is we have to do it on the other side though. So we're going to get two new equations. 210 divided by 6, which is 33. That equals B minus C. You'll notice I'm flipping it around. I much prefer the letters on the left. Then 378 is going to be 63. Equals B plus C. As complicated as the problem was up until now, this is basically like one of those ones earlier. Remember where I had x plus y equals 49 and x minus y equals, I think, 13. This is what we got. Look at this. It's already good to combine them. B plus B is 2B. C and negative C cancel out. This makes 96. We divide by 2. B equals 48. So apparently the speed of your boat in still water is 48 kilometers per hour. That's pretty fast, I think, for a boat. All right, now you got to go back and find the current. You can plug it into the originals, but I would not plug it into the originals. I'd use one of these ones down here, especially the second one. Because that's B plus C, so 48 plus C equals 63, minus 48 on both sides. C equals 15. That's a toughie. The setup on that one is Oh, wait, did I do some math wrong? Wait a wait a minute. Uh-oh. None of my answers were right. I didn't plug it in at all. Correct at all. Oh, now that explains it. Let me just make sure I'm not stupid on the other one. Okay. Ha. Whoops. Let's make some adjustments. Oops, it's upside down. When you suck, you gotta admit it. This was not 33. This was 35. So sorry. I didn't do 210 divided by 6 correctly. And that would give me 98. And 98 divided by 2 would be 49. And then when I minus 49 on both sides, I would get 14. Sorry, it's 49 and 14. Maybe I should have checked my math first, huh? Okay, 2 misses would have definitely made me a little spooked. Alright, so let me start that again. So the setup is difficult because the distance equals the rate times the time. The rate is something minus something and something plus something, depending on if you're going upstream, downstream. Or maybe your problem is with the wind, like a plane goes with the wind, and then against the wind. I don't know. It varies, right? And my advice is, if there's a number at the end, which there will be for the time, instead of distributing it, I would probably subtract it. That way you're left with very nice stuff that can cancel out later. And don't be a goon like me and make sure you check your work. I should have known 210 divided by 6. Yikes. What was I thinking? Oh well. It is what it is. Submit assignment. By the way, there's not going to be one of these distance equals rate times times problems. I do want to show you this. Let me go to the report and show you what you're in for. So when it comes to test time, you're looking at 3 kinds of problems. Problem type number 1, these problems with these setups. And the setups for this one, I can't show you it again, but it had y equals this, y equals that. I set the x stuff equal to each other and work it out. So there's going to be one of those. Then we had one of these problems where it was talking about the numbers, like the sum of the numbers, the difference of the numbers, 3 times as large as a number. I saw one that said, did I do that one? Is that what it changed? Wait. Number 4 was the difference. Oh, it still has that one. I did another one, but it didn't replace it. All right, I had one where it was like 7 less than the other one. There's going to be one of those, so be prepared. And then 5 through 8 here was just a big smattering of all the other things. I think the one on the test you'll get will look like 5 or 6. 5 or 6 is meant to be a little easier than 7 or 8, but they're both supposed to be similar. So 5 and 6 were like this one. 8x plus 4y equals 37. 3x plus 2y equals 17. And then we multiply some stuff and do elimination or whatever there. And if you watch the video, you saw it. Why are you still listening to me? I don't know. Well, hopefully that helps. Hopefully this works good. Because last time I put a video up on YouTube, the sound was weird. And what's worse is I changed my headphones since then. So hopefully it's not picking up double input like it was then, because that was my issue. Guess I'll find out when I upload it. Am I right? Alright, hope this video served you well if you watched it. I appreciate you watching the videos. Mostly because I know it's going to help you do better. That's it. And I'll see you on another video. Probably. Maybe. We'll think about it. Okay, bye.